We'll now move on to example 3, where we're going to use the string library comparison function to have the user type some additional information on the command line. The user is going to type the string -rows, followed by an integer string with a number of rows, and the user will type the string -cols, followed by the integer number for columns. Right, this is, there's no assurance the user will type rows first and then columns next. So let's look at these examples. A.out would be the name of the executable. So they might type A.out -rows, then 54, -columns, 36, or they might type -columns first, -rows second. All right, so what we want to do is we want to alter our example then to compare the string to -rows. When there's a match, we want to treat the next argument as the number of rows, and then the same with -columns. So let's take a look at how we can alter our example here that we just did. We called practice 2. Right, we wrote this function to parse the command line. We just assumed that argv1 was the number of rows. So we want to take this example now and alter it. Right. So let's save this file. Save file as practice 3. And add that to the project. We'll remove 2 and make our changes here. Right. And now the user has to type at least 5 things on the command line. Right. I gave you an example called Parse 2. I'm going to pull this out for these comments. Here are the comments that you want here. So the program is going to require a minimum of 5 command line arguments because we still want the rows and columns. So here we were then comparing this to 3 before because we wanted them to have the name of the executable, the number of rows, and the number of columns. Now we want, if this is less than 5, we want to go ahead and display some sort of error message here that says something like, we want you to type -rows, some numeric value, maybe I'll just give it 4, then -cols, right, and then maybe a 5. They can type other numbers, but we want them to type something along these lines. And then we want to call our parse command line function. Now, our parse command line function still has the same requirements in terms of we want to extract the number of rows and the number of columns. So we're not going to change our function prototype. We're going to call it the same way. We're going to change the behavior in here. All right. So let's take a look at, we know we're only going to call this function when our argument counts at least 5. Right. And once we're in there, we'll want to perform a string comparison. We want to then say something like if. And so the string library has this function, string compare. Right. And so we're going to call then strcmp for string compare. We're going to pass to it, well, if we pass to it argv at index 2. So let's take a look, right? Argv index 0 is the number of executables, actually argv at index 1. Argv at index 1 should be a string. If I compare that to -rows, when they're the same, remember string compare returns a 0 when they're the same. Then I can say, okay, I can use my pointer that points back to rows, the variable points back to in main, so I use the indirection operator. And I want to store in that variable then, well I want then, actually this is what we want. So let's just copy this in here. Right, we're altering this, but now this isn't argv at index 1, it's argv at index 2. Because remember, the first thing they've typed is -rows, the next thing they've typed is the number of rows. And then I could say, I could also check if string compare argv at index 3, compare that to -cols. If that equals 0, right? So if this function, string comparison, returns 0, that means they're the same. Let me put this comment up here. We'll extract the number of columns from there, right? But now this would be argv at index 4. Put this comment here, extract the number of columns. Right. That works then. Remember I said the order isn't specific, but let's just get it to work for this case now. Let's build this. And warning, unused parameter argc. All right, it's complaining that I'm not doing these other things down below. Let's go ahead and set the program arguments here. So now just 4 and 5 won't work. I need to have dash rows, right? And then I said I want my 4 space dash calls, right? You have multiple spaces and 5. There are my arguments. Now here, remember I still call the function the same way. I still want to check to make sure rows and columns are equal 0. If they're not, I should be able then to go ahead and create my array. This is complaining that I have an unused variable array because we're not doing anything with it. So I'll ignore that warning. All right, so let's just go ahead and do a run to cursor. All right, when we call our function and we're inside here, so now string compares argv at index 1 is rows. Right, what that should do is this should return true. So I say next line, it does. When string comparison, so when this function, the result of calling this function returns a 0, that means that this string is equal to this string. We'll just go ahead and then set rows, right? We're going to convert the string 4 then to an integer and store that in rows. And similarly, right, if we were to add here, well, what's stored at argv at index 3? What's stored at argv at index 4? We're going to see then argv at index 3 happens to have columns. Right, argv at index 4 then extracts that, stores it back in here. Back in main, we have our 4 and 5. We have our good condition. We'll declare our array. And so we got it to work in that particular case, right, which is a good starting point, right? Sometimes you don't want to worry about this complication of whether or not these can be different. If you can't figure out how to handle that right away, simply because you haven't done it before, then you can write something very specific and get it to work in this manner and then take a look at, well, how do I get it to work for when things are the opposite, right? If they're the opposite, we'd know that this would be at argument 1, this would be at argument 2, this would be at 3, and this would be at 4. We can actually then write something that looks more like this. We could say for int I equals, we can start I at 1 because we want to start with argv at index 1. I less than argc, right? Plus plus I and we can wrap this inside our for loop. And now just compare argv at index I. If that's the same as rows, then we want to store in rows what's at I plus 1. And here, compare this to I, and then you want to store what's at I plus 1. And now you want plus plus I here. We want I is equal to I plus 2, right? Because when we do this, we're going to use up I when I is 1, and then 1 and 2. So we'd want this to be at index 3 next time to skip over here. And then this will work for 3 and 4. So let's then do a run to cursor. All right, so inside here, notice, right, I didn't change the program arguments. argv at index 1. So I will be set to 1, right? I is 1. So now it's going to compare. So if argv at index 1 happens to be rows, right, it's going to compare this string to this string. If they're the same, right, this function will return 0. and they are in this case. We'll assign rows to that. Now, the way this is written, it's going to still compare argv at index 1 to columns. That's false. So we come back up here, and then it will increment I by 2. Right? So argv at index 3, well, that won't be equal to rows, but this one will be equal to columns, and we'll extract that. All right. Let's make this condition an else if, because if this one's true, we know the next one can't be true, and we'll just save a comparison each time. We'll save some operations. So let's rebuild that. Let's run the cursor. Okay. So once again, we have the same set of arguments. Now let's just see we save a comparison. So I is set to 1. Argv at index 1 will be equal to rows. This will be true. We'll set that. And notice we didn't have to come down and do this comparison. We went right back up. We're going to set I equal to 3. Right, this will be false, so now we'll come down and perform this comparison, which will then extract the number of columns. Right, we go back to main. Rows and columns have their 4 and 5. Right. And then let's just try one other thing. Let's change the order of the arguments. Right. Let's put dash cols first. And dash rows second. And all we did was change this particular order of the arguments. So run the cursor. Right. So now we can see then argv at index 1 has columns. So this then, let's set I equal to 1. Right, when we compare this, this won't be equal to rows, so it'll come down and perform this test. This will be true. We'll extract the columns. I will be set equal to 3. Now this will be true. We'll get rows. We'll come out of the loop. We'll come back. We'll come back to main. We'll still have our rows and columns. So now, simply by writing this, we started by writing a case that worked for a specific order. We noticed the pattern and changed this then and closed this within a loop so it could work for either order. So we made those changes one at a time. So incrementally make those changes. If you can't immediately see how to write it to work for any order, get it working for one, and then you can work on getting it to work for any order. Meaning this might not always be the order, right? But in my comment, we have an idea here of how to work with this, right? And that's what we wanted to do then for part 3. Right, we treated then that next argument, or we treated both of these cases. So now you have an example of how to use the string comparison function. That you know how to write a parse command line function. You know how to return multiple items using pointers. You can use the string comparison then to make sure that the users entered this argument, right, to indicate which are rows, which are columns. And you should be able to now proceed and do your strings homework where you'll write your own parse command line function. We typically use these same forms all the time with parsing the command line.